Okay, hello. So I think there was some problem with the recorder. So I'll continue the same example here. So we have already seen that just adding the values here and interleaving the transaction in between, and we are multiplying it by 3. Okay. So moving on with that, we are writing a value here again. We are changing towards it that we are reading the value of y, and y is equal to y is now a different data item. So you can add the value to 5, and then you can write the value of it. Okay. So now see, this is S1 and this is S2. They are both following the same transaction. They have the same transaction, but here S1 is a serial transaction and S2 is a non-serial transaction. Okay. Now check the result here. First one is check the result here. Suppose the value of R is X is 100. So here it will be 105. So I write the value of X is 105. Okay. Value of Y is 200. So I'm writing the value of 200 and suppose 205. And then we are writing the value 205. Okay. Similarly, when you read the value of X, it will be 105 because it is already being written here. And you're multiplying it by 3, so it will be something like 115, 50, sorry, 350, and you're writing the value to be 350. Okay, so at the end we got the value of X to be 350 and the value of Y to be 205. Okay, so if you are able to get the same thing here, you can say that S2 is a serializable schedule, result equivalent schedule to S1. Okay, so check here again, it is 100, you are adding a value to 5 plus, it is 105. Again, the value is read as 105, multiplying the value to be 315, and you are writing the value to be 315. Again, the value is 200, 205, and you write the value to be 205. So, what is the value of x? X is 315 and value of y is 250. Okay. So, you're seeing here the result at the end are equal. Okay. So, a non-serial schedule is producing the same effect as a serial schedule. So, you can say that S2 is serializable, and moreover its result serializable. Okay, so it is result serializable. So I can also give you an example of a non-serial schedule if I want. Okay, so suppose the same transaction here, what I'll do, uh, uh, I think that that's enough. Okay, so you can take another combinations of a schedule, you can find another serializable schedule, so it is possible. Okay, so now moving forward with conflict equivalent schedule. So this is one of the most important point here. Okay, so conflict equivalent schedules. Okay, so before moving on to the conflict, that we have to remember some of the conflict operation that we have seen in previous videos. That there is something called we have already seen problems, that is read conflict, read write conflict. So these what are conflict operation that can occur here? So these, what are the conflict operations? So we have to see. Okay, so if there is a conflict operation, we have to mark it and then we have to check. Okay, so what is a conflict operation? Suppose there are two transactions Ti and Tj. Okay, so if TIA is reading the transaction and another one is writing the transaction, so this is again a conflict operation. If TI is writing a transaction, another one is reading the transaction, so it is again, you see, it's a write read conflict. And then there is another, and one is writing the transaction, another is writing the transaction same, so it is referred to as a write write conflict. So these three are referred to as the conflict operations. Okay, so these are conflict operations. Okay, so non-conflict operation can be that when you are reading the value of A and another one is also reading the value of A. So this is not a conflict operation. So the thing will occur here, no problem will be faced here. Okay, so that is why it is referred to as a non-conflict operation. Keep that in mind. Okay, so another one is that if they are acting on a different data item, that will always be a non-conflict operation. Acting on different data item. Okay, different data item means that that suppose this reading the value of A, and another transaction T2 is also writing the value of B. Okay, so these two are different data items, so there will never be a conflict. So this is not a conflict. Keep that in mind. If a transaction working on different data items, there can never be a conflict. Okay. Now, going back to the conflict equivalent definition here. So, two schedules. So there are two schedules, S1 and S2. So again, the same particular definition here. Two schedules are referred to be conflict equivalent if again S1 and S2, either S1 is a serial schedule or S2 is a serial schedule, or S1 is a non-serial schedule or S2. So if S1 is a serial schedule, S2 have to be non-serial schedule. Okay. So if S1 is a serial schedule and there are some conflicts, the same conflict occur in S2, then they will be called as conflict equivalent. It's as simple as that. Okay. So I'll give you an example here. It will be more clear. S1, two transactions. You can take any number of transactions here. So I'm just taking two transactions. The same transaction I will take in a serial mode, and the same transaction I'll take in non-serial. Okay, so I'm taking S1 in a serial mode here. So suppose R A W A R B W B. So this is serial and everything is complete. Now we are moving towards another transaction, R of A W of A. Okay, so just to be clear, I'm just writing 1 in the subscript here 2 because it's a part of transaction T2, so that is why, because I'll write the conflict, so not to get confused between these two. Okay, now a non-serial transaction S2, R1A W1A, then I'm changing towards it, R2A W2A, then again the remaining part, R1B W1B. Okay, so these two are different data items. So there will never be a conflict between B and A. Okay, so check here. What are the conflict that will arise from here? So read is never a conflict. So read and write is the first conflict. So first conflict is read 1A and write 2A. Read write conflict. Okay, so this is the first. Another one is write read. So it's again a conflict in same data item. Write of A and then read of A. Okay. Another one is write conflict also there. So write one of A followed by write two of A. Okay. So now read one of B and read two of A. This is not a conflict. Everything is acting on different data items. So these are the three conflicts that you will find in the schedule list. Follow the same here. If you are able to do that, the same thing. Read one of A and read two of A is not a conflict. Read one of A and write two of A is a conflict. So you can write it like that. Read one of A, write two of A is a conflict. Second conflict will be write read conflict. Write one of A followed by read two of A. It's a conflict. And another conflict will be write and write conflict. Okay, so you can see here both of these conflict for the same order as well as it's the same thing. Okay, so you can say S2 is conflict serializable to S1. I can simply say that because we're able to find a non-serial schedule that is producing the same effect in terms on conflict to S1. Okay, so keep that in mind that the transaction or sorry, the schedules are conflict serializable. So S2 is conflict serializable. Keep that in mind. You cannot say S1 is a conflict serializable. Okay, because S1 is a serial schedule and the serializable property follows around the main part of serializable property is to find a non-serial schedule that produce the same effect as a serial schedule. So this is what we want. Okay. So in order to understand more here, I'll solve more questions here. Okay. So I'll give you one or two more questions. So schedule. There are two schedules again given here. R1A. Suppose this is given to you. Schedule 2. Okay. So try to solve it. Just pause the video and try to solve it. I'll tell you the answer. Okay. So just pause the video, try to solve it. Is there conflict equivalent or not? And then you will find. So now I hope that you have paused the video and tried. Okay. So what is the solution of this? So schedule S1. There are two transactions. 1 and 2 indicate the number of transactions. So T1 followed by T2. R1A, R2B, W1A and W2B. So this is a non-serial transaction. Here S1 is a non-serial transaction. So maybe S2 will be a serial transaction. Okay, so R2B. Okay, so it is again a non-serial transaction. Yeah, I think it is a non-serial transaction. So I don't think that you will be able to find the result here. Okay, so check it. Okay, check it. R2A, R1A, W2B, W1A. Okay. So first of all, we already know that if S1 is a conflict serializable or S2 is a conflict serializable, you have to have a serial transaction. Okay. So there is no serial transaction here. If you are seeing here, there is no serial transaction here. So either you go ahead and write a serial transaction, either the serial transaction that you will find here in this schedule will be uh, two serial transaction. Okay, either T1 followed by T2 or T2 followed by T1. So you can do that, but again, it will be a lot more hectic. Suppose if we have three or four what do you say transactions, so that will again further increase the number of serial transaction will further increase. Okay, so before getting to the answer here that how to solve it, that this is not possible that you will generate all the serial schedules here and then you do and then you try to uh, match the conflict equivalency. That will be a lot more hectic. Okay, so there is a way that you can avoid that. Okay, so there is a way that is referred to as a precedence graph part. Okay, so in this I'm just giving you an example here that S1 and S2 schedules, but here there is no serial schedule given here. So one way will that you can generate two serial schedule and you can test out the conflict equivalency. Another way will be that you follow the precedence graph method. Okay. So before going into the precedence graph method, I just want you to do a little more practice on the conflict equivalency property. So I'll give you another question here. So just try this one. So I'm not giving you the solution here right now because it is not solvable in this current form. Okay, the only solution will be that you have to get the serial schedule and then you can match it one by one. So that will be a little more hectic, but just follow this one. So I'm giving you a serial schedule as well as a non-serial schedule. Okay, so W1A, R2A, W2A, R1B, W1B, R2B, W2B. Okay, similarly schedule S2, R1A. Okay, so try to solve it. Pause the video and try to solve it. Okay, so I hope you tried to solve this one. So I'm writing the schedules here S1, and S2 transaction T1 followed by transaction T2. Okay. So again, I'm writing whatever is written here on the schedules here. R1A, W1A, R2A, W2A. If similarly schedule S2, so this will be a serial schedule in this case. Okay, so it is written here. Now check the conflict that are being possible in this case. So just okay. So read of A and read of this is not a conflict. Read of A and write of 2. This is a conflict. Okay. So right here the first conflict that you are faced with is read of A followed by write of A. Okay. Another conflict. So this is a different data item. So this is not a conflict here. Okay, so now check for this one, write of A and read of A. So this is again another conflict. Write one A followed by write two A. So this is one more conflict. Check for the third one. So write is also a conflict. Write one of A and write two of A is a conflict here. Okay, another conflict. I think this will be again another conflict because they are working on the same data item. So read and read is not a conflict, but read and write will be a conflict. Read one of B. So this is your fourth conflict. Fifth conflict will be write read. Sixth conflict will be write write. Okay. So now check here. Check the same thing. Read of A it's not a conflict. Read of A, write of A is a conflict. So it will be again read of A, write of A. So this is a conflict. Now write of A and read of A it's again a conflict. Now check again. And write of A and write of A it's again a conflict. Write of A followed by write 2 of A is again a conflict. Now check for this part also. Read of A and read of B, sorry it's B here. Read of B and read of B is not a conflict. Read of B and write of B is a conflict. So fourth conflict will be read 1B, then write 2B. Similarly, write 1B, write 1B, read 2A, read 2B, and then there is a write conflict. Okay, so check here, the order is same, everything is same. You can say that S1 is conflict equivalent to S2. Okay, so this is one way that you can do that. But again, if you are not given a serial schedule, that will be a very difficult task. Okay, so now the next particular kind of question that you will find, that you will only be given a non-serial schedule, and then you have to tell that this particular schedule is serializable or not. Okay, suppose uh, this is a question that is given to you T1, T2, or we can take the same question about which one, right? Because both of the transactions are already, what do you say, non-serial, so I can take both of those schedules. Okay, so just wait 1 second. I was not able to copy it. Okay. So I think I can now. Yeah. Okay. So now I'm just copying this particular question here. Now, now I'm only taking in this particular part. I'm taking schedule one. Okay. So taking schedule one, and I want to say that if this schedule is conflict serializable or not. Okay. So first way is to generate all the possible serial schedule, that is T1 followed by T2 or T1 T2 followed by T1, and then you match the conflict equivalence. Another way that we will follow is second method, because we are not here, because if there are, I think, three transaction, there will be 3 factorial, I think 3 into 6 possible serial schedule that will be there. So we don't want that. Okay. So second method that we follow is a method of precedence graph. Okay, so if you are able to get a cycle, then you can directly say it is. I'll tell you about what is a cycle or what not. Okay, so check here. Now, what is the conflict here? Read one to read two. This is not a conflict. Read one to read write two. It's also not a conflict. So there are two transactions T1 and T2. So I don't think there is a conflict between read one, write two. And again, there is no conflict between from read to A, because they are working on a different data item. Okay, so there is no conflict that you will find here. Actually, there is no conflict here. So that will not be a suitable question for this, because actually there is no conflict here. So how can you give a conflict equivalence question? Okay, so just let me change the question here, because if there is no conflict, there will never be. You can that directly say that S1 is conflict equivalent. Similarly, S2 is also conflict equivalent, because in serial schedule there will not be a conflict. Similarly, in non-serial schedule there will never be a conflict. Okay, so just think of it like that. Okay, so I'm changing the question here, T1 and T2 again, so such that there will be a conflict that I can write. Write one, write A. Same question I think we have done earlier, but now we are not. You are not given what do we call a serial schedule in this with this. Okay, so write the transaction T1 and T2 like this. Okay, so now check the conflict. The conflict is from transaction T1 to T2. So you write the arrow like this. Okay, transaction T1 to T2. Read write conflict is there. Yes, absolutely there. Similarly, write write conflict. So one arrow is enough to indicate that there is a conflict from T1 to T2. Okay. So now check here if there is a conflict from T2 to T1. No, there is no conflict from T2 to T1, but again there is a conflict from T1 to T2. Okay, so that in that case we have already written an arrow here. Okay, so if there is an arrow here, already written arrow. If there is no cycle here, okay, so you see there is no cycle. Cycle will be like that. If there is a conflict between T1 to T2, suppose this is the same data item A here, then there will be an arrow from T1 to T2 as well. Okay, so if there is a cycle there, if you are able to form a cycle, then you can directly say that it is not conflict serializable. But in this case, there is no cycle. You can directly say that schedule S1 is conflict serializable. Conflict serializable. Now, the main question is that to which serial transaction it is conflict serializable. So it is again in the precedence graph. So which serial transaction? T1 followed by T2. It means to this serial transaction that firstly T1 will be completed RP WB, and then your T2 will be completed RA WA RP. This is the same question that we have done earlier. So precedence graph is not only telling you that a particular schedule is conflict serializable, it is also telling you to which particular serial schedule is the schedule S1 is conflict serializable to. So that is the main benefit of following this particular method. Okay, it's very easy. I think anybody can easily do it. Okay. So just keep in mind, if there is a cycle, then there is no conflict serializable property. If there is no cycle, only then you can say it as a conflict serializable. Okay. So I'll give you one more question so that you can try to solve it. Three transactions. So we'll more focus towards the questions here, because the more practice you do, the more you will understand how this conflict serializability works. Okay. So pause this video and try to solve this particular question. Okay. So again, you have to follow the precedence graph. I'm writing T1, T2, T3. You can write in any way. So our main task is if you are able to generate a cycle. Okay. So now R to Rx, this is not a conflict. Rx to Rx is not a conflict. Rx to Wx is a conflict. Okay, so you can write T1 to T2 arrow. Okay, move on towards the next transaction in time. Okay, so don't go right directly here. Just move on to the next transaction in time. So here you interleave towards T3. So I'm going towards T3. Okay. So Rx, Wx, this is again a conflict here. You can easily see from T3 to T1. T3 to T1, I'm writing an arrow here from T3 to T1. If you are able to find T2 to T3, then there will be a cycle. Okay. Now moving on towards the next transition in time, there will be Wx. So this is already being done. Wx to Rx, again T1 to T2, T1 to T2 is already given, and Wx to Wx, it's already given there. Okay, so you will not be able to find the transition from T2 to T3, or you can. T3 to T2 is again, there is a conflict here. You can see from T3 to T2, Rx Wx is also a conflict. So from T3 to T2, there is an arrow. Okay. See here, it is not a cycle. It is the cycle is not forming. Cycle will follow this direction. Okay. So this T3 to T1, T1 to T2, and if there is a T1 to T3, then there will be a cycle. But this is not a cycle. So you can say that it is conflict serializable. The schedule S1, so I'm writing it as S1, is conflict serializable. Now the main question will be that to which serial schedule it is conflict serializable to. Okay, so it's a bit more tricky here, because there are three transactions involved. Okay, so you can solve this by topological sort. Okay, so topological sort. So I'll just give you a little bit of introduction about the topological sort. So topological sort works on in degree. Okay, so in degree means, suppose this is the graph. In this particular case, the in degree of T1 is 0. Oh, sorry. The in degree of T1 is 1, because T3 has an arrow towards it. The in degree of T2 is 2, because there are two arrows coming towards it. And the in degree of T3 is 0. Okay? In degree of T3 is 0. So how can you arrange this transaction? Just follow the path here. Path will be, the least in degree is T3, then it is followed by T1, and then it is T2. Okay, so T3 followed by T1 followed by T2 is that serial transaction. The schedule S1 is serializable to, conflict serializable to. Okay, so this is how you solve these types of questions. Okay, so just for more practice, try to solve this question also. It's a very good question. We'll try to do lots and lots of practice, because these questions demand more practice. Okay. So RA. Okay, so try to solve this. Take your time, pause the video, try to solve this question, and then you can again unpause and see the solution. Follow the same method. Okay, so I hope you have paused the video and tried to solve it. Now check it. Check the conflict from the time. So the first transaction is RA. So RA is not a conflict. RAWA is a conflict. Okay. So you can directly write there are one T1, T2, T3, and T4. So from T4 to T2, you are able to find a conflict. So I'm just writing T4 to T2. Okay. Any other transaction? No. Any other conflict? No, there is no other conflict. Okay. Another will be your RA. This one is the next one in time. So RA to RA, RB, WB, different data items. So there is no conflict here. Okay. Not able to find any conflict. So this is done. This is done. Now the next transaction in time is this one. T3. So T3, I think this is a conflict here. Okay, RA to WA. So T3 to T2. T3 to T2 is a conflict here. Check any other conflict? No. So this is again completed. Okay. So now the next transaction in time will be WB. So you can see the conflict here. WB here and the conflict here. So T1 to T2 and T1 to T3. T1 to T2 and T1 to T3. So these are the arrows I've written here. Now the next transaction will be WA. I don't think there is any conflict here, okay, because the upper conflict are already being dealt with. Now WA there is no conflict. WB there is no other transaction to be conflicted from. Oh, sorry, from RB you can find that there is a conflict. T3 to TA, okay, T3 to TA, T3 to T. So T3 to T2 are already being written. Okay, so I think it's done. Yeah. Okay, write the in degree here. So there is cycle. Is there a cycle? I don't think there is a cycle. There is no cycle here. So that I can say that schedule S1 is a conflict serializable schedule. To which it is conflict serializable? To which serial schedule it is conflict serializable to? So check here. Write the in degree. So here the in degree is 0. In degree 1, 2, 3. In degree is 3 here. In degree is 0 here. In degree is 1 here. Okay. So I think 0 and 0, these are two that has the same in degree. So there can be two particular schedules, serial schedules, that this particular schedule will be conflict serializable to. Okay. So I'm writing this T1, then followed by T4, then it is followed by T3, and then it is followed by T2, or T4 followed by T1, T3, and T2. Okay, so these are two serial transactions to which this schedule S1 is conflict serializable to. Okay, this is how your topological sort works. Okay, so I think okay. So actually, how actually to solve it again? There are more to it than you can see. Okay, so let me again give you a little bit more here. So start with it. T1, T2, uh, T3, and T4. Okay. So check here. I'm just writing the arrows here. 0, 3, 0, 1. Okay. So how actually to solve it? There is a little than more particular analysis involved in this. Rather, I have talked about. Okay. So check here. When you're writing T1 here, okay. So I've written T1 here. So you have to delete all the arrows here. Okay. So if I deleted the arrows here, now you have to again calculate the in degree. Okay. So in degree in this case now will become 1. Uh, yeah, now this is correct. Now, which one will be the next one? It will be T4. You're absolutely sure. Okay. So when you write T4 here, again delete this part. Okay. So when you write T4 here, delete this part. You will find the in degree here is 1, and the in degree here is gone to 0. Okay. The next transaction will be T3 followed by T2. Okay. So this is one way that you can do that. Another way can be, because there is uh, more transactions that are being involved here. So I'll try to do it. Okay. So first one we have already seen that I have given you two one T1 T4 T1 T4 T3 T2, and you can directly write T1 T4 T1 because both of that have the in degree 0 0, and then you write the same thing T2 T3. Now can any other topological sort that can happen here? Okay. So try to solve the same way. Okay. So I'm just writing the same thing here. This one, this one. Okay. So check now. First it is 0, 3, 1 and 0. Okay. So now I am writing T1. First I am writing T1. So where the written T1, this one will be gone. Okay. This is gone. Now it becomes T1 becomes 1 and 1 and 0. If you're seeing, sorry, it's also becomes 0, I think. Yeah, it's the in degree here is 0 and in degree here is 0. Okay. So you can see there is more possibility open up now. Okay. So T1 followed either by T3 or by T4. Okay. So T3, T4 is already being done, but T4 is not done. T3 is not done. Okay. So T1 followed by now T3. Now when you do that, what will happen here? T3 is gone. Now again there is a two particular serial transactions that you will find. Okay. So sorry, the integrity here is 1 and integrity here is 2. So it is T4 and then it is T2. So you're seeing here that we are able to get one more serial transaction from the topological sort. Actually the procedure of the topological sort is like this, that you have to do it like this, that you have to just delete that part where you have already been considered. Okay, so if the transaction T1 is considered, you have to delete it and again calculate the in degree. So that is much more, what you say, much more effective and much more how you do a topological sort. Actually, this is how topological sort is done. Okay. So because when there are more transaction involved, just follow this procedure, because when there is less transaction, there will not be any kind of a need here. You can be easily able to solve these things. Okay. So now another question that I want to give you. This is a GATE question, GATE 2004 question. So you have given four options, and they are asking which of the following is a conflict serializable. So I will just give you a options here and try to solve it. I'll tell you the solution in the end. I'll tell you the answer in that. I will not tell you the solution because I think you will be able to solve it now. So I'm writing the four options. You just have to find the conflict serializable schedule. Okay, so X is the same. So just don't think that this is a different data item. I'm writing X the same thing. Okay, so try to solve this and try to find which of them is a serial schedule. So I'll just try to give you the answer here. So pause the video if you do not want to know the answer in the end. Uh, and the answer is D. Okay, so this is the serial schedule which is conflict serializing. Okay, so try to solve it one by one. I think you can easily be able to do it now. We have done enough questions. Okay. So I think you have understood the concept of conflict serializability. So thank you for listening this one, and now we'll try to cover the view serializability part in the next one. Okay. So thank you for listening. See you in the next one.